The universe is vast, but honestly, it's stranger than we ever imagined. Every time we think we understand it, something changes the rules. A light that shouldn't flicker, a signal that comes from nowhere, a particle that shouldn't exist, yet does. Scientists call them anomalies. We call them mysteries. From invisible forces shaping the cosmos to ancient explosions hidden in plain sight, these are the facts that defy logic, the truths we still can't explain. Welcome to Stellar Stories, and here are 10 mysterious facts about the universe that might never be solved. Number 1. Oumuamuas unexplained. Push. In 2017, something strange entered our solar system. It wasn't a comet, it wasn't an asteroid, it was something else. Oumuamua, Hawaiian for scout, was the first known interstellar object to visit us. It tumbled through space at 196,000 miles per hour, and as it passed the sun, it sped up. But here's the mystery. There was no visible outgassing, no tail, no jets of vapor to explain the acceleration. Comets do this, rocks do not. Some scientists suggested exotic ice sublimating, like hydrogen or nitrogen. Others proposed something even wilder, a fragment of alien technology, a light sail pushed by sunlight. We may never know the truth. Oumuamua is long gone, but whatever it was, it didn't behave like anything we've ever seen. For decades, scientists had a problem. Half of the universe's normal matter, called baryons, was missing. Not dark matter, not dark energy, just regular atoms, the kind that make up stars, planets, people. Cosmology said it had to be there, but telescopes couldn't find it. Then, something strange happened. Astronomers noticed distant radio signals were twinkling, like starlight through water. The cause? Something vast and invisible, rippling in the darkness. In 2024, scientists found what they believe is a cold, dense gas filament, nearly a third of a light year long, floating through the Milky Way. It was invisible to normal telescopes, but it warped radio waves, revealing itself like a ghost caught in a mirror. Billions of these filaments could be scattered across the cosmos, hiding the missing matter in plain sight. The universe might not be emptier than we thought, just better at hiding. Sometimes the universe hides its biggest events in plain sight. For over 20 years, a powerful cosmic explosion was sitting quietly in NASA's Chandra X-ray Observatory data, completely unnoticed. It wasn't until scientists went back and reanalyzed old observations that they spotted it. A colossal blast, far beyond our galaxy. And, honestly, we have no idea what caused it. It wasn't a typical supernova. It wasn't a known gamma-ray burst. Whatever it was, it released more energy than hundreds of millions of suns combined in just a few moments. That is hard to believe, but true. No one saw it in real time. No alarms went off. It just happened and faded into the background. How many more of these cosmic needles are hiding in our data? And what kind of objects, what kind of events are powerful enough to leave a mark like that? Sometimes the universe doesn't just whisper its secrets, it screams them into the void. And you know, we only hear them decades later. In 2007, a strange radio signal crackled through the universe. It lasted just milliseconds, but it was powerful, and it was coming from outside of our galaxy. Astronomers called it a fast radio burst, an FRB. Since then, we've found hundreds more. Some are one-time events. Others repeat, sporadically, with no pattern at all. Some come from the hearts of distant galaxies. Others from ancient stellar graveyards. One came from a magnetar, a highly magnetic neutron star. But not all of them do. And honestly, no one knows exactly what causes them. Could they be colliding stars, cosmic strings, or something else entirely? They travel billions of light years to reach us, brief flickers of unimaginable energy. And for all we know, they could be happening all the time, all across the sky. We just haven't built ears sharp enough to hear them all. How fast is the universe expanding? It sounds like a simple question, but the universe refuses to give a simple answer. When we measure the early universe, using the cosmic microwave background, we get one number, about 67 kilometers per second per megaparsec. But when we measure nearby galaxies using exploding stars and other tools, we get a different number, about 74. This disagreement is called the Hubble Tension, and it's not going away. In fact, the more precise our measurements become, the worse the tension gets. Some scientists think there's a flaw in our models. Others believe it could point to something deeper, new physics, an unknown force, a crack in the very fabric of our cosmology. Whatever the cause, one thing is clear: the universe is sending mixed messages. And somewhere between 67 and 74, there's a secret waiting to be found. Right after the Big Bang, the universe made three main elements: hydrogen, helium, and lithium. We can predict how much of each should exist using physics, and for hydrogen and helium, the numbers match perfectly. But lithium, there's a problem. Ancient stars, some of the oldest in the universe, have only a third of the lithium we expect. It's not missing because we can't see it. It's just not there. Did the early universe destroy it? Are stars doing something we don't understand? Or is there a flaw in our nuclear physics, one that's hidden for 13 billion years? No theory fits perfectly, and every solution opens more questions. It's one of the strangest inconsistencies in Big Bang theory. A tiny atom whispering that something big might be wrong. The universe is filled with invisible particles, so tiny they pass through everything, including you, without even a whisper. These are neutrinos, the ghosts of the cosmos. The cosmic neutrino background, or CMB, is the ancient relic of the Big Bang, left over from the birth of the universe, 380,000 years after the explosion. It's still out there, drifting through space, carrying the history of creation itself. We can't see it, we can't touch it, but we know it's there, leaving subtle imprints on everything from galaxy formation to the cosmic microwave background. Detecting these neutrinos directly, that's the holy grail of cosmology. It would unlock secrets about the early universe, before stars, before galaxies, even before atoms. So far, we've only detected them indirectly through their effects on matter, but the hunt continues. Somewhere, floating in the cold vastness of space, the cosmic neutrinos wait, silent and unseen. KIC 8462852, better known as Tabby's star, has baffled astronomers since its discovery. It's a star that doesn't behave like any other star we've ever seen. Over the course of several years, Tabby's star flickered in an erratic and mysterious pattern. Not a gradual dimming, like what we see with exoplanets passing in front of stars. No, this was something else. It plunged in brightness by up to 20% and did so unpredictably. At first, many speculated alien megastructures, perhaps a Dyson sphere, might be responsible. But as time went on, scientists dismissed that theory. Instead, they turned to the possibility of huge clumps of dust, or even the remnants of a disintegrating exomoon. But the true cause? Still unclear. Tabby's star remains one of the most puzzling cosmic phenomena we've ever observed. A flickering enigma, calling out from the heart of the Milky Way, reminding us how little we still understand. Quantum redshifts the universe's subtle shift. In the vast, empty stretches of space, light travels across unimaginable distances. But what happens when that light encounters the universe's most fundamental forces? In the 1990s, scientists discovered something strange about the light emitted from distant galaxies. It was redder than expected, not just a bit redder, a subtle, mysterious shift that couldn't be fully explained by the expansion of the universe alone. This phenomenon is called quantum redshift. It suggests that the light passing through space might be affected by quantum processes we don't fully understand. Some theories propose that light isn't just stretched by gravity, but subtly altered by the quantum structure of space-time itself. Others speculate that it might be due to interactions between photons and dark matter. What's baffling is that this redshift doesn't follow the simple rules of cosmic expansion. It hints at something deeper in the fabric of reality, something that might link quantum mechanics with the large-scale structure of the universe. The quantum redshift suggests that the universe might not just be expanding, it might be transforming on a level we haven't yet grasped. The universe shouldn't exist. According to the laws of physics, the universe should not exist. In the early moments after the Big Bang, matter and antimatter should have annihilated each other, leaving behind nothing but pure energy. Yet, here we are, surrounded by matter, galaxies, stars, planets, and life. How did we get here? The answer lies in a mysterious imbalance. For reasons that remain unclear, a tiny excess of matter over antimatter was created during the Big Bang. Just one particle for every billion antiparticles. That tiny fraction allowed the universe to survive. If the balance had been perfect, there would be no stars, no galaxies, no planets, no us. This imbalance, this matter-antimatter asymmetry, is one of the greatest unsolved mysteries in physics. It suggests that the universe's very existence is a fluke, a cosmic miracle that goes against the laws of symmetry. And we may never know why the scales tipped in favor of matter. The universe shouldn't be here, and yet here we are, standing in the middle of it all, trying to understand why. As we peer into the vastness of space, the more we uncover, the more we realize how much is still hidden from our understanding. The universe is full of strange anomalies, deep mysteries, and paradoxes that challenge the very fabric of what we know. Every discovery leads to more questions. Every answer unravels a new riddle. And yet, it's that uncertainty that makes the universe so incredibly fascinating. Who knows what new secrets will emerge tomorrow? For now, all we can do is keep searching, keep wondering, and keep exploring. Thanks for joining us on this journey through the cosmos. Don't forget to subscribe to Stellar Stories for more cosmic mysteries, mind-bending facts, and stories that will make you rethink everything you know about the universe. Until next time, keep looking up, because the universe is always ready to surprise you. See you next time.